Right. So the when Tom approached me to join, we figured out that we would need some sort of SLA monitoring, and I put together the first version that's currently running with the following design principles. And what I'm going to do is I'm going to go through what those design principles are, why I took those decisions. I've already got a slide here for gaps. There are some gaps in the design. There are also some gaps in the functionality. And then at the end of that, let's just open up the discussion for ideas and comments and that sort of thing, and then see where we go. We know that there's quite a bit of work to be done to go to the next level, and we'll talk about what the functionality is that's needed in the next level, and then we'll open it up to whoever's on the call to find out where you think you want to or could contribute, and we'll see. We'll kind of make a tech team and just have a go. Yeah. All right. So just a little bit of a background then. The purpose of the monitor is, the purpose of the IBP is, of course, that the members provide services and receive rewards. One of the things that we're keen on is maintaining the standards of service. And in order to maintain standards of service, first of all, you have to have them, and they need to be measurable. Otherwise, it's very subjective. So in order for it to be measurable, there needs to be an SLA, and then it needs to be some way of doing the measurement. And of course, that brings in the IBP Monitor. We stick to some ethos or code of conduct, and this has also been put into some sort of words for the IBP itself, and that's largely to promote decentralization, to promote open source, and in all of our workings to be open and transparent. So what are the monitoring targets at the moment? At the moment, each member should be running system chains, parachains, and also hosting some form of being able to run WSS via Polkadot.js. I'll just point out that this WSS is not the same as multi-address as this WSS. Okay, because this WSS is proxied to the WS port, whereas I understand that this WSS is proxied to the P2P port, to my knowledge. Anyway, so that's what we need to, those are the monitoring targets. We should all be running 3 boot nodes for system chains and 6 RPC nodes. Somebody's joining. Who wants to come? Tom wants to join. Hey, Tom.
Hey, I was just gonna join in and listen if that's okay.
Yeah, I'm completely fine. Just as usual, to let you know we're recording.
Okay.
This for the website. Right. So we should be running, as I said, 3 boot nodes, 6 RPC nodes. This is 2 each, so that you've got resilience. And I think these are the ports that should be open for boot nodes. I don't know if WS and WSS should be open. That's open for discussion. And if they are or should be open, then of course they need to be monitored. And then for parachains, you should be running, I said here 6 boot and 6 RPC. That's 6 individual parachains. At the moment, I think they will go up to 8 or 9. And in our current design, well, at least certainly in my current design, I'm running the parachains that are piggybacking off of one of my RPC nodes for the relay chain. But if you're going to run your own relay chain, then you will need to run an additional system chain per either Polkadot, Kusama, or West End. Okay. So when we're thinking about what to measure, the first thing that we want to measure is the service up? Is it available? And second of all, you want to measure, does it perform well? The first one is easy. you either make a port connection or you do some general testing. The second one could be, and I need your input on this, could be either subjective or difficult to calculate, because what we're trying to work out is we're trying to work out network latency, and of course that's going to be different compared to if you're in your own data center monitoring your own servers, or if you're on the other side of the world and you're on a dodgy 3G connection. So we need to think about how we monitor aggregate latency and determine if somebody's inside or outside of SLA. Okay, and then another challenge that we have is to monitor the SSL certificates, the dates for them, and it's going to be complicated if we're going to be running over GeoDNS, because wherever you are in the world, you want to get to rpc.ibp.network, and of course your DNS server will just resolve that, or the GeoDNS service will resolve that to an IP address that's closest to you. So we need to work out how do we do that sort of work. I've got ideas around these, by the way. Right, moving on then to what are the actual requirements? This link is deprecated. I'll just go there quickly just to show you. This is my brain dump of what we should include in the monitor. I will remove this from the wiki because it's largely irrelevant, because I've moved on quite a lot from this design, so don't worry about that. Then we started on the wiki a list of SLA checks, and I'll just open that. And this is according to the text of the proposal, what we should have. So each member should have a certain bond of 5,000, or the amount that, if, for example, if you've entered the 1 kV program with a lower amount of dot, if you've entered based on intention, then whatever dot you were allowed in. And then some ideas around what the technical SLA should be. You should be able to dial. There should be some security checks. So you should not have RPC equals unsafe on your nodes, those sorts of things. We can test for those. We have got a target performance of less than 100 milliseconds. And at the moment, most nodes are achieving that. If you just have a look at
Costa Rica, I think we are out of the.
Yeah, so for example, if we just look at what the checks are that are achieving, you can see most of them, some of them are a little bit higher, but most of them are well underneath 100 milliseconds. Not wanting to dox anybody.
Yeah,
That's green. Not wanting to dox anybody. How's it work? I'm looking at. Okay.
Derek, just a question. What, from where is it measured? Is that like inside the node or just from an endpoint?
Yeah, I'm going to go through that so you can see exactly how it's currently measured, and then I'd like your ideas about what really should be measured. Okay, so so that's the target, milliseconds. We might find that it's unattainable, but for most people, depending what's measured, the way that it's working right now, it seems to be attainable. Who's coming in? Kabi.
I just want to clarify, though, that I mean, like, everybody's going to have a different network latency, and a lot of these locations are meant to, well, all of these locations are meant to serve their local population. So the latency from one site to another site is really kind of irrelevant, which is why I was so focused on response times rather than network latency times. And the only reason I really talked about network latency was just to say that in order to get the response time, we have to have a response time that is network latency adjusted. And what that means is we take the network latency out of the response time sum so that we get this network latency adjusted response time, which means that the response time would be the actual time that it took the server to receive a request, process that request, and send the results back out, taking into account the fact that the server that is checking it is somewhere else and could be 50 milliseconds away or 100 milliseconds away or 200 milliseconds away.
Kukabi, hi, just to let you know that the session's recorded. Okay.
All good. Hi.
Yeah, thanks. Okay, so what we can do is we can get certain information from doing an RPC call. So we could see the number of peers, for example, if we want to make sure that our nodes are configured to accept the right number of peers, whatever. Then under the reliability, we want to make sure that the nodes are on a relatively modern version. I know for 1 kV, you've got to upgrade to the latest within 12 or 24 hours, can't remember. We need a statement here as well, and it might not be feasible to upgrade within 24 hours, but so we should check for this. We're currently not checking for it. By the way, and I've got some ideas as to how to get the latest version from the repo. You get the latest version like that, but it doesn't. How to check the latest version? You have to go to telemetry, and if you look at telemetry, it will give you the version that the node's on. And I think you can only get that if you if your node is actually sending telemetry. I haven't found an RPC call that you could do to get the node version. Happy to work with whoever's got experience in this. I thought it was like
there is actually.
Yeah. Here it is, but it's in a different format, and I'm not sure if it says spec version, but it doesn't say node version. It just happened. It just is that the same? Is that the same value? And can we just parse this as a number and somehow get that out of it?
Yeah, parity always codifies that.
It doesn't work like that. Because sometimes the node version is ahead of the spec version. So, for instance, now we're on 99380, but the spec version is going to be behind. But I work quite a bit with telemetry. I know how to fetch the data and how to parse it, etc. So I can contribute around that.
Super, excellent. Okay, so this is just again, there are gaps here, and I'm really gonna appreciate your feedback as we grow what we want to measure, because this is all still around SLA monitoring and right, moving on, security. So the only thing under security I've got is that the RPC methods equals safe should be the default setting. You should not be doing unsafe, and this should fail. So you should not be able to get the list of peers. I believe if you can get the list of peers, that will help people to be able to triangulate as to where your server is in the world. It's not so important for us because our servers are known, the locations are known anyway. But anyway, right. So back to the presentation. That was the SLA checks that I thought we would do. And then I started thinking, well, actually, what we should have is we should either have a backlog or we should have issues, and then everybody can see what's being worked on, and then you can do pull requests to close issues, because that's just probably a better way of working. So I started this issue, which takes the previous page a little bit further. So it's the same: availability, performance, reliability. I'd like some ideas around member rank, because in all of the professional levels and even in the hobbyist level, there's mention of the rank should be, and you get X number of points for doing something, but I haven't got my head around how we increase and decrease member rank. If, for example, if somebody has a 15-minute outage, and the name's mentioned, could be me, then, you know, for every day that you're down, or for every hour that you're down, do you lose some score? We'll talk a little bit more around this. And then we started just copy and paste message from Tom here about we should all run our services off of the 2 domain names, and then we should use internal DNS to switch. If you wanted to do rpc.dotis.network, but you wanted to test my services, you'd have to know what my address is, my IP address is. And then there's a way of doing this in JavaScript, and I'm sure there's a way of doing this in Perl or Python or whatever scripting tool we want to use, where you can just say, go to the domain name. You could do a get onto that domain name, but you could provide your own DNS internally. You don't actually go out to google.com or whatever it is to do the DNS. So that will allow you to use those 2 figures combined. I'm not convinced that we should only do that. I think we all have to answer this call anyway. For example, rpc.dotis.network and also rpc.ibp.network. We should all be answering these if they are geo-DNS'd to us. But I'm not convinced that we should be using the main networks for monitoring the where is it? These sorts of addresses. Let's discuss. I'm not saying yes or no. Anyway, so where are we? This is where I am now proposing that we monitor or keep a list of our development backlog as either issues that have to be solved, or in the as an issue with some sort of tag or feature request or something like that. Okay. So where are we with the actual monitor itself? This is the architecture. I'm running an Express.js application, and that Express.js application has got all the HTTP routing, handlers, etc. And the front end is a Vue.js extension called Vuetify, which basically binds in, I think it's material design user interface. It's not Bootstrap, is it? Either material, I think it's material design, and a front end with loads of useful components. And that essentially is the front end is Vuetify, and the middleware is Express.js. And in the middleware, we've got various handlers. And then I was thinking, what do we do for the API? And it concerned me that if we used something like REST, then all the endpoints need to be known. Now, because we're a relatively small group of people, we could just share the IP address or the host name where each of our endpoints is going to be. But it concerned me also that if there was a central point for monitoring, and that central point was far away from some of the services, those services might feel that they're getting a raw deal or a bad deal because they're so far away and the monitoring isn't favoring them. Tom has already said we need to somehow extract the network latency from the server response. That may or may not be possible. We need to see how that actually works technically. So what I landed on was this library called libp2p, which is essentially the networking layer of all of our nodes anyway. Polkadot and Kusama and West End and all the parachains, they all use libp2p in their networking as the networking layer. So I went for that, and it works pretty well. You can see if we look at these checks, you can see the source of the data comes from either this particular node, and this particular node, you can see this node, because it's using libp2p, the monitor itself has a peer ID as a validator would have, but the monitor has a peer ID. And you can see that if there's a little check mark here, this particular monitor did a check and got a result. But what you might also find is that if you just scroll through, this is a particularly busy monitor, but there are also, you should see some checks coming through. Where are they? Nope, that's not working there. Let me just check.
We are just too good.
Yeah.
There's another check on there at 3045199.
Thank you. Yeah. So what you can see is that this monitor has done a check on a certain URL and has come up with a result and has sent that via something called the gossip protocol, which is on top of libp2p. So if we had, I don't know, 10 monitors and they were all joined to the same network, to the same gossip network, they would all get the messages. So the way that I was designing it is that each monitor, and I'd like each member that's running nodes for the IBP, I'd like them to run a copy of the monitoring software. And the way that that would work then is if you are configuring, I'll just show you the config file. I can't see what's going on. Different. If you're configuring the monitor to run locally, then you would configure the services that you've got, and that would be published to the rest of the world. And then you would listen for others. So for example, here you've got config.local.js, and here you configure where are they? You put your services in here. So at the moment, because this is on my development machine, that's my internal testing node for Kusama. And if I opened up the one that's running on another node, you would see that I would have, I don't know, all of the Metaspan nodes configured. And you can see on here, if you look at the monitors, you can see that there are 3 monitors. This is my development machine, which is not running right now. Okay. That is Tom's machine. It's running on a virtual machine in Tom's infrastructure. And this one is the current monitor that you're looking at. And the monitor that you're looking at is advertising these services. So this monitor is advertising these services, and it's advertising these services to the rest of the network. So if I was running, I don't know, Gato Tech's monitor, what GatoText monitor would do would be connect to this monitor and see, you're advertising these services. Let me test them. So that means we all test the other people's nodes, so that you will get, for example, if GatoText was running a monitor and State Plus was running a monitor, they would all test this particular service. And they'd gossip to the rest of the network to say, hey, I've just tested Metaspan's Kusama endpoint, and this is the response that I got. So we could see from all of the nodes around the world, not the nodes, sorry, all the monitors around the world, we could see perhaps what's the aggregate. Or we could see that, I don't know, if you're in Japan and you're monitoring the US, you get a really bad result. But if you're in west of US and you're monitoring east of US, you get a really fast result. If that's interesting, just stuff that I was thinking about might be interesting when I was designing the monitor. Anyway, so with libp2p, there are some ways of sending messages to your peers without actually knowing where they are, which is really great. You just tell the protocol, you drop a message onto the protocol, and it just squirts that message to the whole network, which is great. That's why I chose libp2p. We have a data store, and the data store is using something called Sequelize, and Sequelize is a wrapper around SQL databases. The two main databases that I've implemented and tested are SQLite and MySQL. So if you look at the database structure, let me just log in here quickly. This is loosely what the database structure looks like. There's service, table, and each of the services are listed here. This is a database table version of what you get in the config file. So in the config file, for example, these guys would have been advertised in my config file to the rest of the network as soon as my node, my monitor, hears on the gossip protocol of a new service. He goes, I don't know about that service. I'll put it in the services table. And then later on, I'll run, when I run the health checks, I'll just run a health check on that new service, which I've just discovered. So that's a service discovery. Okay. And this services table is what you see there. So the database that I've opened up is a development database. And of course, it's got much fewer records. That's the services table. And what I noticed is that some of our services are load balanced. Our RPC services are load balanced. So depending on how you are load balanced, you actually connect to a different node. So I started collecting peer information. And the peer ID is what makes your node unique. And you can see the peer ID, for example, behind these. Those two are the same. That's the same service, but it's got two peers, as you would imagine, because that's load balanced. I'm not sure what we're going to do with this yet, but it might be that one of your nodes is running really poorly and the other one runs really well. You might want to know that sort of stuff. So if you get a really bad result from your health check, if you look at the health check, for example, we'll just go into this one here, you will actually see the peer ID that gave that response. Okay, so this is the monitor that ran the check. That's the service URL, and that's the peer ID that gave the response. And then the rest is, we have to decide what we want to put in here, and then the reports are going to run out of that. Okay, so I'll come back to the rest of this design. This is not yet implemented, but it's part of what I'm thinking we'll need as we need to break out the health check process from the front end process, because the health check process it takes long, and the more services that we are bringing online, it's just going to take longer and longer and longer for the health check process to run, and we don't want that to interfere with the database or the reporting side. So I think we'll have to split out the jobs. I discovered Bull MQ when I was reviewing the design for the back end of the 1KV functionality that Will from Parity has designed. So I started playing with this Bull MQ, and I really like its capabilities. And what it requires a reader's queue. But what it allows you to do is it allows you to spin up workers that are independent and just listen for events to say, hey, there's a new event, I need to do some work. And that's how it's allows you to get really good performance. Some of the features, so I will talk a little bit about this in the next slides, but some of the features that we already know are missing is to monitor for outages. Okay, and also once we discover events that are interesting, to send alerts. So I'll talk about those a little bit later. One of the things you may have noticed that is if you go into a service, for example, and you look at this graph, this is just me trying to, in a visual way, show whether the SLA is good or not. If you get to 500 milliseconds, you'll see that there's a red line in this graph. And if you go above 500 milliseconds, we were thinking that is a reportable incident, but I haven't seen 500 milliseconds for a long time. But what I found recently is that if there's a gap, for example, if there's a 3-day gap, this graph doesn't show it. It just neatly carries on, you know, all the data that is reported. So that's a defect that I've already opened up on defect number 1. Yeah, the performance graph does not show outage gaps correctly. So if you don't rely on this graph to show you the outage gaps. So we need that. Right. If you'd like to know, I can tell you a little bit more about the front end, how it's glued together, what the storage is. We know about that. Any questions up until now? Let me know. Oh, sorry, BRD, I didn't see your hand. You have a question?
Yeah, no worries. That was just for the end of your presentation. So that's great especially to use the libphp because it's like direct query of the nodes. So that's pretty interesting to get, you know, response from this part. For the other part, just had, you know, an idea in mind, but I don't want to sound like a maximalist of these tools. But you know, I'm using every day a stack based on, you know, Grafana and Prometheus. So of course it's kind of centralized, but it's very efficient. And yeah, that's basically the message.
Thank you. Yeah, I am still learning Prometheus. So, but in the short space of time that I've been spending on this, I think it's probably going to work for us. We just need to learn how to use it. Right.
I could give you a session on this. Would be my pleasure.
Yeah, I would appreciate
but
that.
Yeah, because I mean, basically, if you have something, well, of course, this implies some things like, you know, the nodes, like operators have to allow the nodes to communicate the Prometheus metrics. Well, but in the end, what it means is that, you know, each substrate node has a Prometheus exporter agent that is running inside the node. You probably many many of you use it, to get basic.
We're all using this. We're all using
Yep.
this sort of stuff, right?
Yeah, pretty much. So this is pretty
I don't
helpful
think-
to get chain metrics, but it's also useful with some some add-ons. Well, it's not really add-ons. It's even some some little programs on their side. But if you use, for example, the one called Black Box Exporter, it's very useful for probing. You can probe any kind of endpoints. You get the response time. You get the SSL certificate expiracy. Yeah. So, well, clearly this stack works well, but just of course not forcing to it.
Thank you for that. I've got 3 more slides, and then let's open it to more to the floor for the discussion. Right, let's just keep going.
Yeah, sure.
This slide. Why did I choose a P2P? Well, because it's decentralized. We can do this via REST. The only thing is that if you wanted to share, if you did a health check on somebody else's node and you wanted to share that with the network, you'd have to make the number of calls that we've got, the number of monitors. So I think there's an efficiency by having libp2p. There is currently we have to remember that I have not built this on a blockchain. So if your monitor server is down for a couple of hours and there are messages on the libp2p protocol, there is no message queue. So when your monitor comes up again, it won't resync like a typical blockchain node does. So you'll be missing some messages. And that's one of the questions that I've got in the for the group is how close do we want to get to running a blockchain? And if we're going to get that close, aren't we at some point better off just creating a solo chain, potentially at some point a parachain? Don't know. It's a lot of overhead, but you get a lot of benefits. So we can discuss that. I'm not sure if that's even in the budget for us to develop this as a solo chain or a parachain. So that's why I chose P2P. Let's just run through some known issues that I've already identified. Happy for you guys to add to these known issues if you want. The presentation layer, as I said, is currently connected to the backend. So if you're running reports on here and you click on there, for example, and it freezes, it might be because there's heavy lifting going on in the backend because it's doing some health checks. We need to separate those two. My proposal would be to create some sort of job queue, and I've already done some prototyping on how to do that in BullMQ. Okay, the second known issues is service outages themselves are not detected and therefore they're not recorded. So in the design of the database, I guess we need to have some sort of events table. Yeah, this is the health check table, and in the health check table you will see there is a text field, and the text field holds whatever you want, just a load of JSON. We could also switch to MongoDB if you guys want. It would require not a lot of work, but that might be more flexible or less flexible. One of the things I tried to do is to consider whether this database should be run sort of as an embedded database. And that's why eventually I chose SQLite. So SQLite with the right number of indexes is really fast. You can see there's no problem here with regards to querying. How many is it? Not that many. On my version of the monitor, I am keeping data for 7 days. On Tom's version of the monitor, we are keeping data for 30 days. And here you will see the performance is not as good. And I'm wondering if that is just because I'm missing an index. But this is running off of SQLite, and you can see the performance is not that great. But I suspect right now, Tom's monitor is running health checks. And the way to check that is to go here and to see if we get some gossips. No, not straight away. Anyway, so it's a known issue that we need to separate the presentation layer from the back end. We also need to create an outages table or an events table. It might not be an outage, it might just be slow service. Or it might be something which is outside of SLA, for example, an expired SSL certificate. And in those events, we should be able to report on the events. That's what I'm thinking we'll do. Okay. Another thing is that the health check ID is just an integer, a long integer. And this is the next number for the service that's doing the check. So the health check, this is just, if you look at the structure, it is just an int and it's auto increment. So if I send this health check, which is 229566, if I send it out via the gossip protocol, this is a check, for example, I sent out. Whoever receives it doesn't respect this number. Is that important? We have to think about that. But in order just to get the product out and to get it to start working, I just created local IDs for the health checks, and we sent them out via the gossip protocol. Even a UUID would be an enhancement of this process, so we could then send it out, and that's not a problem. Okay. When we separate the components, when we separate the front end from the back end, we need to think about database access, and that's when SQLite won't work. So we'll probably have to use a proper database or a database server, probably go to MySQL or something like that, because SQLite doesn't support concurrent access. Okay, and then something we need to discuss, for example, this is, I wouldn't say it's a wrapper, but it's a higher level service, because underneath that we've got each of our individual services that are, this is the geolocation that will come to us if we are the ones closest to the user. And we need to think about, are we going to stick with this long list of services, which is going to grow even longer when everybody else puts on their parachains, etc., or if we're going to go to a short version. And we can restructure this actually. Maybe if we look at the front end and say, instead of going straight to services, maybe we could go to a members page. And then inside of a member, you could just list the services that the members got. Maybe that's kind of what you get when you look at the monitors. So if you look at the monitor here, you should just see the services advertised by this monitor node. Open for discussion there as well. And then on the final page, I start having ideas about how we would structure our development. Don't want to be too formal about it, but I think that we should have who's coming? Paolo. Back. I think we should think about how people can contribute. Maybe not everybody's a software developer. Maybe somebody could be a tester or an administrator. If we have admin screens, for example, if you wanted to bring your nodes out, if you wanted to take one node down for maintenance or whatever it is, and you don't want to run the monitor for a bit, maybe we should have a screen here that allows the administrator of this node to change its status, because at the moment this is calculated as to whether you're online or not. And if you get 3 outages, you go into stale, for example. Don't know what the rules should be around that. Just stuff I've been thinking about. That's so maybe we could have administrator roles, technical administrators. There are people who could test, obviously, that's great. There are people who could write how-to documents or admin standard operating procedures, SOPs. And I'm not sure we need the role of evangelist, but that was just me thinking out loud. So I think I've done most of the talking. Of course, I've done most of the talking because it's a presentation, but I'd like to hear your thoughts. If you want to go around the room, if anybody's got some thoughts, what's in the chat? Sorry, Milos, I only just looked at the chat.
Well, as you know,
Is that
got a few ones, but yeah.
Yeah.
What I'm just feeling in general here is I think you're maybe trying to recreate a part of tools which already exist and are open source. So maybe this could help, yeah, to lay on some existing tools and of course tweak this, but it would basically save you some time.
When you say existing tools, are you saying, and can you give some examples?
Yeah. I mean by creating a database that you extend, pretty much. Well, that's actually a great design, you know. I'm just thinking in general, it's maybe not like super necessary to create and extend all of this while you have well, especially like time series database solve most of the problems you're referring to. So when I think about time series database, I think of course about Prometheus, but yeah, it has a way to manage database in a time series manner, which means low space, low resources usage, and access to history too.
Yeah. The time series database.
Just thinking out loud.
Yeah, but let's have it, right? Because there's no. Time series database, in my experience, is great for exactly that, time series, but we need to understand what it will be used for, because it's just useful for rollups. You can't typically do SQL related stuff on them, but let's investigate how we could do time series. Yeah. Any other comments?
I guess I would just like to say that the general goal of this application specifically is to kind of formulate the things that we would need in order to eventually roll this into a system chain. I see the monitor as.
Can you guys hear Tom?
Hello?
Yep.
Yep, loud and clear.
Sorry, it's just really quiet. Sorry. Carry on, Tom.
So one of for the IBP monitor specifically, I see this as a solution where we could allow anyone to operate this on their PC through their web interface, which would actually give us better network latency statistics, since we're looking for information that is that is within the region. And since all of our nodes are currently regional, we have no way to check like local latencies. So yeah, I guess I would just like to say that, I think that this would make for a really good system chain, and I would like to see it move in that direction, and that's kind of why you see things like libp2p being used in kind of these decentralized databases and things like that.
Also, you mean using a system chain for storing, basically storing monitoring data?
Well, I mean, a system chain for the IBP specifically that would allow anyone to come and become a candidate to operate services for not just the relay networks, but also the other for-profit parachains and system chains, so that any parachain or any relay chain could come to this system chain and say, we need a relay node in this location, or we would like one in this location. And then we can think about things like how should we connect to these networks, and we can work out ways to bootstrap access to the parachain so that applications like Polka.js wallet can actually find these nodes and find these nodes more optimally than using an Anycast or GeoDNS solution, like essentially a custom connection handler.
Yeah, we need to take that as a networking topic, I think, because we don't want a layer. We need to consider if we're going to implement a layer between the user and the node, because that's a loss of trust.
Well, the reason why I was suggesting that we implement a layer between the user and the node is that, for instance, we have the rpc.ibp.network and we have the daughters.network. If one of those two is offline for any reason, then that appears as offline. But if we have a connection handler that would, for instance, connect to both of them simultaneously, and then whichever one opens the connection fastest is the one that is sent the connection handler to the application itself. So it's more like a way to determine the most optimal location. It's like a GeoDNS built into the application itself.
Cool. Let's have a look at that. Any other questions or comments? Because what I think we can do is go and have a look at the ideas around what
I just threw out a couple of questions in the chat.
Oh, hi, Dennis. Yeah, keep going.
Sorry, if you want me to say it out loud. So basically, on behalf of Parity, I would like to ask pretty much everyone who deals with DevOps and Parity nodes to provide the feedback of like what would you like to have implemented in Parity node from the DevOps side, so it would be it would be more comfortable to work with it. Like for instance, have more endpoints for health checks, the ability to provide more metrics right away from the node, and I could basically deliver them to the engineering and prioritize these issues for them.
I think what would be really interesting is if the node, whenever there is a direct RPC call, which generates a direct response as opposed to a subscription, that those RPC calls include the time it took to generate that response. That information is critical for us to determine whether or not a member is operating their node on NVMe drives, or whether their NVMe drives might be substandard.
Yes, we actually don't deliver any hardware information, and that would be really great. Because for instance, right now we cannot even tell if the node is running from the Docker or from the Kubernetes or from some specific VM machine, and what's the operation system, what's the environment of the virtual machine.
Yeah, like some sort of general health information, just like what you were describing, would be amazing too, like on an RPC endpoint that we could query.
Yeah, thanks.
That's all I can think of off the top of my head, but if I think of anything else, I'll reach out to you.
Yep, thanks.
I definitely reach for some metrics I could be interested in, but won't use the meeting right now. It's a bit detailed.
Please share BLD when you want.
Oh, yeah, sure.
Either in this chat or go back to the members matrix, probably better.
Mm-hmm. Yeah.
Yeah, I like this idea of getting more technical details about the node. We have to be careful because most of the interesting data is protected by RPC equals safe, or methods. RPC methods is safe. Okay.
No. Yeah. RPC methods safe basically ensure that you don't call, especially some things like session palette or some things related to identity, or to like attach the node to one single entity or operator. But I don't think it acts on version or performance. But basically, until now, at least, you have to choose if you want to get info from the node. You can choose the basic version, which you have inside the API from the RPC, or the Prometheus exporter metrics. Honestly, the Prometheus exporter metrics are much more complete, but also, you don't want to expose everything to public. There is no real sensitive informations, but it's maybe a bit too much to expose everything to public. But an interesting piece is, to rely on this, aggregate the data. I mean, on my side, I'm using Grafana. It's one of the most used tool, I guess. And then you can, share the piece of data that you want, and you can integrate in any website. So that's pretty much a good idea. I would have maybe just a general comment, Derek, is there are a lot of topics, and I think maybe something interesting to separate is what are the important metrics to make sure the infra is providing good service, good uptime and SLA. And there is another one which I'm it's maybe a bit interested, but I'm more interested is the overall performance and estimating the distribution of the different members. So it's not purely about performance, but it's give a global image, because IBP is worldwide, and I mean, to me, it would be extremely valuable for everyone to have a global image of who is processing what, so that you can focus on region specificities, and also estimate the next members, which region should be targeted for the next members, because if one region is getting...
You've just reminded me of something like that. One of the things that I want to add is somehow, and maybe this is something we can get from involving Dennis, is if you want to see how many requests your node has served in the last hour or in the last day.
Oh, I got everything for this. Don't worry.
And if you know what are the RPC calls that people are calling, or are they just using Polkadot.js for? Well, you won't know. Maybe you will know. If that's something, how would you get that from a node? How would you get those statistics to say, I don't know, the node has been called 500 times in the last minute, or because you can't monitor for it on WebSockets, so it's very difficult for us to put monitoring capabilities in between the client and the endpoint.
Now the node has very good embedded tools, and actually the Prometheus exporter metrics do that. They do even bucketed list of requests with response time. Of course, it's just internal to the node, so you don't measure latency, but you have everything about request in this. If you want, I can give you a very quick look on one of the nodes if you're interested to see. But yeah, that's basically you have a lot of informations inside the embedded metrics.
Basically, the way that it would work, from my understanding, is that the Prometheus exporter is just a REST API endpoint, and we would just pull this when we pull everything else with the monitor. You would pull in the data, and it would have like a cumulative number of requests served, and then you would just take that number and subtract it based upon the previous number, and that would give you the total number of requests served within a given time span. From there, you extrapolate out to whatever minute, hour, whatever that you want.
That's kind of how it works. Yeah, because actually it's the Prometheus database, like central database, that scrubs the metrics from each node it's connected to. Maybe Derek, may I share my screen for a second, maybe?
By all means, do that. I was just thinking that there is a complication, and I'll pick this up with you again later, Tom, and anybody else who's interested, is that in order to get data directly from a node, you can't go through a load balancer. Carry on, BLD, if you want to share. You can't go through a load balancer because you can't be sure which node you're going to hit. So if you want node statistics behind a service, you need to say, well, we'll have to say that we're providing a service, and I've already got that, for example, here. You can see that there is a service. That's the endpoint for the service. But behind that service, there are, this one is really old, but there are actually two endpoints. And if you want to get usage statistics for a service, you would have to know that behind that service are these two endpoints. Then you'd have to query those endpoints separately and do some aggregation. So
the other issue maybe is that is it safe to expose the Prometheus port to the internet? Because that's essentially what we would have to do for all these monitors to be able to access them independently.
That's a question that I like because I've studied it pretty much. It's not super safe to expose it to general public, but you have several options. One of these is to create a private VPN between the members, but a more simple one that you don't have to set all the VPNs is basically just to set a reverse proxy on the Prometheus exporter port, which is default is the 9615. Yeah.
I've got another option for you. What we can do is in the monitor, there is something called HTTP handler. You don't have to do it in the HTTP handler. Actually, you can do it in the message handler. In the message handler, this message handler will listen for any messages on the gossip protocol via libp2p. So what you could do is you could gossip from one monitor to another monitor to say, can you please give me your Prometheus data? And then you could get the message back. So you could do that in both directions. It's not synchronous. You have to message out to say, hey, you over there, please give me your Prometheus data, and then it comes back. So what you will do is you put these sorts of here, for example, you've got handle protocol, and the protocol would be, I don't know, what is it? Are you answering a ping? No. Or what you could do is you could say put case.
It's pretty interesting to study on this, to share between the members. Yeah.
Sorry, Derek, are you suggesting that the member would run the monitor that's local to the member would aggregate the Prometheus data and then share it on request to the other members? Or, sorry, I'm just trying to structure this in my mind.
I'm asking because what was being discussed was, oh, we have to open ports and all that sort of stuff. And I'm thinking, no, we don't need to. We've got a networking layer. Use the networking layer that is specifically between these nodes. Nobody else can join. And if they did join, would that be, we would have to think about some security around this to say, well, actually, we're only going to allow connections from known other nodes. We don't need to VPN this or anything. But still, we have an option. So the option then would be to share Prometheus data via a mechanism between nodes. Yeah.
It's really interesting to me because it seems like if everybody is using a local private IP spacing, you could use the MDNS protocol in order to find any particular node within the local network. And then that way we don't have to have any local Prometheus configuration. The monitor itself could just say, hey, where is this one? That one would respond over MDNS, and then you would know where to connect to see that Prometheus data without any additional configuration.
Yeah. The thing about Prometheus is that the interest is to store. Is to store in like to scrape every 10, 15 seconds, the metrics. So if you have foolish stories.
Yeah, it's exactly what we would be doing, except for in this case, I don't remember how long the monitor or how often the checks run, but I think it's like 60 seconds or something like that. Is that right, Derek?
Mine's running 60 seconds. Yours is running every 5 minutes.
So it's kind of a configurable period, but yeah, it would scrape and store that information within every check period.
So in the config, you put config local, put monitoring interval. There is a standard, and if you want to override the standard, so you can say there is there's config for pruning, and the interval, and then there's also somewhere here. There it is, update interval every 60 seconds. So you could. Mine's running every 30 seconds. Even though it says 60 seconds, it's running every 30 seconds. That's on my development machine. This is on my development machine, so I get faster updates. A lot of this stuff is configurable. I think if you just go and have a look at the code, you can find out how it works.
I just shared an example in the IBP group. I prefer that than sharing, sharing screen on a YouTube video.
Okay, guys, I've just been reminded that I've got to go and run an errand, unfortunately, and it's unavoidable. And we have essentially run out of time. What I need to do is I urgently need to drop. I'm sorry about that. I completely forgot about another commitment, and I'm just being reminded of it. So I literally have to drop now. I'll speak to you guys soon. Cheers. Thanks. Bye.
Bye.
Have a good one, guys.
Yes.
Bye, guys.
You do. Cheers.
Bye.
Okay. Bye, guys.